Very good morning to all of you.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Good morning. We have completed with lubricants or something is left? We have completed all the properties. Test of lubricants.
टेस्ट ऑफ lubricants नहीं हुआ है.
No, ma'am.
Okay. So today we will discuss test of lubricants. Before that, do you have any doubt in term paper or project?
Ma'am, one doubt. Ma'am, जो भी ma'am, the topic which we have to choose from unit 1, 2, 3, 4 should be a heading in each unit or related to any unit. We can choose any of the topic.
No, related to any unit, you can choose any topic. There are so many small subtopics. Like if you see fuel and combustion. In fuel and combustion itself, there are a number of things. Coal, okay. Then different types of coal is there. Then carbonization is there. Analysis of coal is there. So different types. In analysis, again, two different types, proximate and ultimate analysis. So based on these small topics, you can choose any one topic. And suppose you have chosen, for example, one boy yesterday messaged me that I want to choose a topic related to graphene. Graphene is a form of carbon only. Okay. So he said that I want to take the topic related to graphene, but graphene is not in our syllabus. So how you can relate graphene to the syllabus? You can see the uses of graphene. What are the uses of graphene? One of the important use of graphene is it is an anti-corrosive agent. It protects the metal from corrosion. Okay, so you can convert that topic. However, graphene is not in their syllabus, in your syllabus, but corrosion is there in your syllabus. So you can take graphene and its application in anti-corrosive agent. Okay.
Okay.
Similarly, proximate analysis, ultimate analysis. In proximate and ultimate analysis, there are a number of drawbacks, there are a number of limitations. So how, by any other method, how can we improve this analysis? Or during carbonization of coal, there are a number of byproducts which are formed. Okay, how we can make maximum from this carbonization? Means there should be some utility of your topic. You just don't have to give the heading that I am making the term project polymer. One student messaged me like that also, that I want to make the term project topic as polymer. So how polymer is a vast thing. It is a vast term. So many things are there in polymer. Different types of polymers are there. All these different types of polymers are having different monomer units. So any one you can choose. You should be very specific about your topic. Take a small thing and then see its applications, where it can be applied. Means for every topic there should be some application which which can make further studies, which can be used for doing the further studies, further research studies. Getting it or not?
Yes, ma'am. And ma'am, word limit?
There is no word limit. In between 10 to 15 pages it should come. Maximum 15, not more than that. Okay, so each and every topic you see, for each and every topic, a small topic you choose from there and see its applications. Now, for one thing, for a single topic, you will find nearly 10 to 12 applications. Likewise, you can make the your own topic. You can choose your own topic likewise.
How many pages?
10 to 15 pages. And format I have provided in the classroom. According to the format only you have to write. And don't just copy the whole research work which is done previously by any researcher. Please don't copy it as it is. Suppose you have chosen the application of polymer, okay, or biodegradable thermosetting plastic. Suppose you have made the title as biodegradable thermosetting plastic. Now, there are different methods. There are different methodologies adopted by different researchers to convert the thermosetting plastic into its biodegradable form. So when you will search by using the keywords or by directly typing the title in the Google, you will find a number of research works related to this field. So at least you go through 5 to 10 research papers. Out of these 5 to 10 research papers, select at least, suppose you have selected 10 research papers. Out of that, after going through all the 10 research papers, select at least 5 research papers and compare these 5 research papers. What is the difference in the methodology? What different methodologies they have adopted for converting it into biodegradable form? For what purpose they have converted? Okay, so there will be difference in the methodology of each researcher. So you can make your own term paper in this manner also. By comparing 2 to 3 research papers, 4 to 5 research papers. Okay.
Ma'am, ma'am, I had to choose a topic from Unit 3, corrosion and phase rule. So I chose the topic corrosion and its control. But I think that it's a broader topic. So should I make a term project on this or should I select a specific topic from?
No, be specific. There are a number of methods of control for corrosion. Na?
No, I mean, can I make my term project on this topic? Because corrosion and its control, it's actually, you just now mentioned that we need to be specific in our topic. So this is actually a very broader topic, corrosion and its control.
Yes, that is what I am saying. The control of corrosion is a big topic. There are a number of methods of controlling the corrosion. So better you choose any one type of control and work on it.
Okay, ma'am. Thank you.
Anyone else?
Ma'am, in types of corrosion, there were two topics: dry corrosion and wet corrosion. So I have chosen dry corrosion. Is it correct, or I have to go for both of them?
In dry corrosion, what you will do?
I have not researched till now.
Okay. In dry corrosion, you can do how it can be controlled. You have to discuss mainly how it can be controlled, because what you have to do in the term project is select a problem and give its solution. Okay. Select a problem and give its solution. Already, so many researchers have given their solution for the same. If you are not getting your own idea for the solution, you can just compare the research work which is already done. And you can give the conclusion as this one is the best.
Yes, ma'am.
Ma'am, we will compare the topics and
if you get an idea by yourself that this can be done, okay, then you can add into it.
Yes, ma'am.
Anyone else?
Ma'am,
Yes.
Ma'am, can I choose
ma'am,
fluid?
What?
Can I choose fluid lubrication?
Yes.
Ma'am, but you have already proved that like a specific number of people, like 18, there are total of 17 students. So you have marked pink, like different colors for different people. So they have to select only according to that color. Like unit 1 is for green.
Actually, the Sagar ka mem has already specified the number of peoples in a particular group, and they have been assigned each unit specifically. So the peoples in a particular group are allowed to choose the topic only from the specified unit.
And after finalizing all the topics, you just make a list of the topics of the whole class. Okay, and either mail it to.
Can't we choose topic out of like what we are supposed to I have been assigned like unit. I have to choose topic from unit 1. So can't I choose any topic from unit 4, ma'am?
Yes, you can. And anyone else who is interested in unit 1, you can assign it to him.
But we need to make sure that topic is not matching with anyone.
Yes, that is what I said. There are a number of applications. Select different applications. There are different number of problems. You can select different problems. Okay. And after CR, please note it down that after finalizing all the topics, when the whole class finalizes the topic, please make a list of the topic with roll number and name. And
Okay, ma'am.
okay, I'll just go through it and then I'll see whether it is perfect or not. If there is any change, I will.
Okay, ma'am.
Okay then. Our lubricants. Yes, we have seen lubricants. What are lubricants? What are the functions of lubricants? What is the mechanism of lubrication? We have seen fluid or hydrodynamic lubrication. Then we have seen how it is prepared. What are the uses of hydrodynamic lubrication and in which places it can be used. Then in extreme pressure lubrication also the same thing we have seen, and then film or thin boundary lubrication, fluid lubrication. Now coming to the test of lubricants. The first test is, we have not yet started this also, neutralization number also is not done.
no, ma'am. The types were discussed.
So the first test of lubricant is neutralization number. The lubricating oil, even if it is highly purified, highly distilled lubricating oil, contain a very small amount of organic acids. They generally contain very small amount of organic acids, or sometimes alkalis also may be present in very small amount. Now what acid comes into the lubricating oil? Because lubricating oil is basically composed of hydrocarbons, and these hydrocarbons may sometimes produce weak acids in the oil. So as a result of this, even if we distill it properly, then also some amount of weak organic acids are there, which gives acidity to the lubricating oil. But if the lubricating oil is fresh, then this amount of acid is negligible amount. But if this lubricating oil has been used once, after one use, the color of the lubricating oil changes and acidity also increases. After second use, this acidity will further increase and the thickness, viscosity is also going to increase, and this color also changes. Initially, suppose it is colorless. After one use, it will become yellow, and after second use, it will become brown, light brown, and after third use, it will become dark brown. So you might have seen our cooking oil also has the same property. Cooking oil looks colorless. Once if we use it, after one use, it changes the color to yellow. After second use, it changes the color to brown. This is why, because of the increase in the amount of acidity and oxidation which is taking place in this lubricating oil. And due to oxidation only, the hydrocarbons which are present in the oil, they get converted into weak organic acids. So neutralization number is defined as the number of milligrams of potassium hydroxide required to neutralize all the free acid present in 1 gram of oil. Any doubt in this definition? Number of milligrams of potassium hydroxide required to neutralize all the free acid present in 1 gram of oil. Clear?
Yes, ma'am.
Now this neutralization number can not only be given as total acid number. This is actually the total acid number. But neutralization number can be represented in the form of either total acid number or total base number. That is in the form of TAN or TBN. This is the definition of TAN. That is the number of milligrams of potassium hydroxide required to neutralize all the free acid present in 1 gram of the oil. What is TBN? It is defined as the number of milligrams of HCl required to neutralize all the free required to neutralize what?
Bases present in lubricating oil.
Is present in 1 gram of oil, that is TBN. Now more the amount of TAN, more deteriorating will be the quality of lubricant. Therefore, the permissible limit of TAN is around 0.1. If it is more than 0.1 in any lubricating oil, that lubricating oil cannot be used further because it will have a high carbon content, it will have a high acidic content, and because of oxidation, it has deteriorated. So it is not generally recommended for use. How to determine neutralization number? You have to remember these reagents. Reagents are 0.1 normal alcoholic HCl, 0.1 normal alcoholic KOH solution, then titration solvent, which is prepared by 50 ml toluene, 5 ml distilled water, 450 ml isopropyl alcohol, all these things. They are going to prepare titration solvent. Then an indicator, that is para-naphthol benzene indicator. Dry indicator 1 gram, we dissolve in isopropyl alcohol 100 ml. Now procedure. First of all, we take 20 gram of the light colored oil, and in this we add 2 gram of our dark colored oil, and we take it in a conical flask. Now we add 100 ml of titration solvent and 30 drops of indicator. 30 drops of indicator solution. We mix it properly well. Now, after mixing, two possibilities are there. Either our solution gets converted into yellow or orange color, or our solution can change into greenish blue or green color. If it is greenish blue or green in color, it means that our oil has alkali. It is alkaline in nature. If our solution is yellow or orange in color, it means that our lubricating oil is acidic. Now we will decide the further procedure. If our lubricating oil is yellow in color, then we will titrate it with 0.1 normal KOH solution taken in the burette. If our solution is green, means our solution is alkaline, then we will titrate it with 0.1 normal HCl taken in the burette. Then we will take the concordant reading if by getting the endpoint. If our solution is yellow, the endpoint will be indicated by the formation of green color. If our solution is green, endpoint will be indicated by the formation of yellow color. So we will note down the endpoint, and this endpoint is going to give us the amount of acidity or basicity present in the lubricant. We compare it with the fresh lubricating oil. In fresh lubricating oil also we do the same thing. So we compare it with the fresh lubricating oil. If it is very high, if the difference is very high, means there is a lot of deterioration, lot of oxidation which has taken place, and now this lubricating oil cannot be used. Got it?
Ma'am, in first line, it is written take 20 gram sample of light color or 2 gram of dark color. So it would be 2 gram of dark color or 20 gram?
It will be 2 gram only of dark color.
Why, ma'am?
Because already this 2 gram oil is very thick. Just to making it in the form of, means to mix it properly well, only we have taken 2 gram.
Okay.
So the significance, knowing what is the significance, it shows the how much oxidation has taken place in the oil. Okay, if the value of TAN or TBN is very high, if it is more than 0.1, then there are greater chances of the formation of sludge by this oil. If this lubricating oil is used, which is having more than 0.1 value of 10, then it is going to form sludge, or it is going to form sticky product, okay, gum-like product, and will not function properly. Next is emulsification or steam emulsion number.
Ma'am, for finding TN or TBN, why you only use KOH and HCl? Why can't you use another bases or acids?
KOH is considered as, we can, in place of KOH, we can use NaOH also. But we have to take only strong alkali or strong acid.
Means we can use H2SO4 in place of HCl.
See, H2SO4 has sulfur present in it. So there are chances of this sulfur also has the property to interfere in between. That is why generally it is not recommended to use sulfur. We generally use HCl in most of the cases. Next is emulsification or steam emulsion number. Emulsification or steam emulsification number. So what is it? When we mix pure oil with water, we observe two different layers. One is of oil, one is of water. But if this oil is not pure, if it is contaminated with different things, then when we mix it with water, it is not going to form two different separate layers. Okay, they are the two different layers are not going to separate quickly. Why they do not separate quickly? Because they are going to form emulsion. They will form emulsion. And after the formation of emulsion, de-emulsification takes place. So just as we mix pure oil with water, quickly two different layers are formed. But if this is not forming quickly, if the two layers do not separate out quickly, it means that first it is forming emulsion, and then this emulsion is de-emulsifying to form two different layers. So this formation, that is due to the presence of these contaminants, the rate of separation of the two layers is decreased. The rate of separation of the two layers is decreased. Now, if this emulsion remains for a long time, if there is large amount of contamination, the emulsion will remain for a long time. It will take a long time for de-emulsification. So, in that case, it is going to form sludge. It is going to clog the pores present in the machinery. It is going to deteriorate the surface of the metal where it is used. So there are a number of problems related to this. So what type of contaminants can be there in oil? There can be dust, dirt, metal particles, acids, alkalis, or soap. If it is present in small amount, then it is going to form emulsion, but the layers will separate quickly. But if it is present in large amount, it will decrease the separation. It will decrease the rate of separation. So based on this fact only, steam emulsion number is determined for different lubricants. So how steam emulsion number is determined? First of all, we take 20 ml of the oil, sample oil, and we pass equal volume of steam into it. We will pass equal, means we are going to bubble equal volume, 20 ml of steam into it. Now what happens? This steam will form an emulsion with the oil, and after some time, after the formation of emulsion, two distinct layers separate out. Okay, two different layers separate out. We will note down the time required in seconds for this known volume of oil to separate out in layers. This time can be given as steam emulsion number. Got it? Got any doubt in steam emulsion number?
No, ma'am.
No, ma'am.
This is the significance is already known to you. What is steam emulsion number telling us about the contamination in the lubricant? Next is aniline point. So aniline point of an oil gives an indication of the possible tendency of deterioration of an oil when it comes into contact with the packing, rubber, sealing, etc. See, when our lubricating oil is made up of hydrocarbons, already I have told you, if there are certain aromatic hydrocarbons present in our oil, then what happens? This aromatic hydrocarbon has the tendency to dissolve rubber. So if this lubricating oil has aromatic hydrocarbon and during packaging we have put a rubber sealing in the bottle, then this aromatic hydrocarbon present in the lubricating oil is going to dissolve that rubber sealing also. It is going to react with that rubber sealing also, and it is going to dissolve it. So this is the specific property of, especially for the aromatic hydrocarbon. If the aromatic hydrocarbon content in the lubricating oil is more, then obviously it will have a higher aniline point. So this tendency or the presence of aromatic hydrocarbon or this tendency of the lubricating oil to react with the packaging rubber sealing can be determined by aniline point. It can be determined by aniline point. So how do we determine aniline point? We mix equal volume of aniline and our oil sample in a test tube. We mix it thoroughly well and then we heat it. When we heat it, both aniline and lubricating oil will form a homogeneous solution. After the formation of homogeneous solution, it is allowed to cool. After some time, after cooling, we observe two different phases, two different layers. One is of aniline, one is of oil. When just at that point, when two different layers are formed, this temperature is noted, and this temperature corresponds to aniline point. Okay. It determines the percentage of aromatic hydrocarbons present in lubricating oil. Got?
Yes, ma'am.
Got?
Ma'am, if aniline point is high, then the lubricating oil is better, or if it's low, then it's better.
If aniline point is high, then lubricating oil is good. If aniline point is low, it means a large amount of hydrocarbon, aromatic hydrocarbon is there.
Yes, ma'am.
Now cloud point and pour point. It is related to the cooling of lubricating oil. When the lubricating oil is cooled or freezed at a proper freezing temperature, in a closed container, when it is freezed, what happens? It changes into solid form, plastic solid form. But before, why it changes into plastic solid form? Due to crystallization of hydrocarbons which are present in it. But before forming this plastic sort of thing, this plastic solid form, when it starts crystallization, it gives a hazy appearance before completely converting it into plastic form, just as the crystallization starts. At that point, it gives a cloudy or hazy appearance. So what we do is we cool the lubricating oil, and when it gives a cloudy or hazy appearance, we note down the temperature at that point. This point is called cloud point. This point is called cloud point. Then what is pour point? When it is further cooled, after the formation of cloudy or hazy appearance, again it is further cooled, and from time to time we take out the test tube in which we have taken this, we take out the cylinder in which we have taken this oil, and we tilt it. to check whether it is in flowy consistency or it is in non-flowy consistency. So a time will reach when the lubricating oil, after even tilting the cylinder, will not going to flow. So that temperature is needed, and this non-flowy consistency will remain there for 5 seconds at least. So that temperature is again noted, and that is pour point. That is pour point. See, the apparatus is given, pour point apparatus. It consists of a small cylinder in which the oil is taken. There is a stirrer provided in the top to maintain the temperature throughout the oil, the same temperature throughout the oil. This cylinder, flat bottom cylinder, is introduced in another cylinder which is generally made up of glass or metal, in which different freezing mixtures are used. These different freezing mixtures give different temperature. They will provide different temperatures to our lubricating oil. Up to 10 degrees Celsius, if we have to maintain the temperature, we will use ice and water. If we have to, and if we have to use a temperature below 10 degree, that is up to minus 12 degree, can be maintained with crushed ice and salt. Minus 26 degree can be maintained with ice and calcium chloride. Minus 57 degree can be maintained by solid carbon dioxide and petrol. So we can change the cooling mixture or freezing mixture from time to time to decrease the temperature. And then we note down the temperature at which the cloudiness appears, that will be cloud point, and the temperature at which the flowy consistency will not be there. That is, it stops flow at least for 5 seconds. So that will be called as pour point. Now, what will be the significance of cloud point and pour point?
Higher the cloud point, lower the cloud point, better the oil is.
It tells us the major significance is, it tells us about the
temperature of when it forms solids, temperature at which it forms solid.
The temperature at which it changes into solid means it tells us about the suitability of lubricant at different temperatures. Okay. Then volatility. Volatility means, see, every lubricating oil, in fact, every oil has some volatile content present in it. So if this volatile content is more, then obviously the quality of the lubricating oil will not be good. It cannot be used at a high temperature. It can be used at a low temperature, but cannot be used at high temperature, because high temperature favors the volatile substance to volatilize out. So volatility is the amount of volatile substance which are present in the lubricating oil. So it is determined by vaporimeter. For determining this, we use vaporimeter. So vaporimeter consists of a furnace which is heated by the gaseous fluid. And in the center of this furnace, coiled copper tubing is placed through which air can be passed. Then a known amount of oil is taken in a platinum crucible and it is introduced in between this copper coils. In between this, it is introduced. And dry air is passed. What will happen when we pass dry air and when this vaporimeter, this furnace is heated? Whatever volatile matter which is present in this oil it is going to vaporize. It is going to vaporize. So after doing this for some time, that is for nearly half an hour, we do this thing so that complete vaporization can occur. There will be loss in weight. Okay, there will be loss in weight of the oil. So initial weight we know, loss in weight means there will be less weight after. So both these weights, difference in weight is going to give us the amount of volatile substance present in the oil. And that can be reported as volatility of the oil. Significance, already I have told you what is the significance. Got? Volatility. Till volatility, any doubt?
No, ma'am.
Okay. Next is carbon residue test. Carbon residue test is done in Conradson apparatus. There is Conradson apparatus for determination of carbon residue in the lubricating oil. So what is Conradson apparatus? It is a very simple apparatus. This Conradson apparatus is placed in a tripod stand. As you can see here, it is placed in a tripod stand. In this, we can also prepare this Conradson apparatus by ourselves because it is so simple. First, we take a crucible, silica crucible or platinum crucible, which are highly resistant to temperature. In that crucible, we take known amount of oil and we place this crucible in another crucible, which is made up of iron. Okay, we will place this crucible in another crucible, which is generally made up of iron, and it should have a cover over it. Yeah. Means this iron crucible should have a cover over it. So what we do is we take lubricating oil into the platinum or silica crucible and we introduce into the iron crucible, and iron crucible is covered with cap. Now what we do is this whole apparatus is covered with another third large crucible, which is also provided with a cover. Now we start heating this with the help of burner. We start heating it. What will happen? Again, the same thing is going to happen. That is, the oil is going to vaporize. It will produce different volatile matter is going to burn completely. And after 30 minutes, the crucible is removed and it is cooled in the desiccator. During volatility, we were not allowing the volatile gases. We are not collecting the volatile gases. But here we will do the whole procedure in a closed crucible so that the volatile matter which is formed does not escape. Whatever solid particles which are present in the volatile matter do not escape. Okay, so we take out the crucible and then after 30 minutes we will allow to cool it in the desiccator, and then percentage of carbon residue is determined. If there is large amount of carbon residue, then what will happen? Large percentage of carbon residue indicates yes, anyone?
Better lubricant.
What it indicates?
Ma'am, please repeat what you are asking so that I can clear.
Composition of hydrogen. It indicates that the hydrocarbon present in the lubricating oil has decomposed at a higher temperature. So again, if carbon residue is present in large amount, that lubricating oil is not suitable to be used at a higher temperature. Okay.
Yes, ma'am.
Then flash point and fire point. Flash point and fire point. It is related to heating the lubricating oil and bringing it into fire. Heating the lubricating oil and bringing the vapors in contact with the burner. Okay, so it is related to this property. So what is flash point and what is fire point? Generally, if there is offline class, then we perform this experiment in the lab. It is done with the help of Penske-Martin apparatus. So what is Penske-Martin apparatus? See, it consists of a large tank. It consists of a large tank, as you can see here, in which metal tank, this is a metal tank, in which oil, known amount of oil is taken. Then this oil, this tank is provided with a cover and a hole for the thermometer. A hole for the thermometer, and there is a shutter control. By tilting this shutter control, there is an, on the left hand side you can see there is an opening, that is a nozzle sort of thing. Okay, there is a nozzle that is written as pilot burner. So a nozzle is there, an opening is there. By tilting the shutter control, we can open the nozzle and close the nozzle. So what we do is we electrically heat this tank. We take a known amount of oil into the tank and we electrically heat it. After heating it, at every 5 to 10 minutes, we will note down the temperature. Because generally the lubricating oils have a flash point, fire point between 50 degrees Celsius to 370 degrees Celsius. So first we will allow the oil to heat at a temperature of 50 degrees Celsius. And after 50 degrees Celsius, we will start noting down the temperature. And after every 10 to 10 seconds, we open the shutter control. We tilt the shutter control and open the nozzle. And by opening the nozzle, the vapors which are produced by the lubricating oil will come out. There, suddenly we bring the burner near it. Okay, we do this thing after every 10 seconds. After every 10 seconds, we do this thing. Tilt the shutter control, open the nozzle, bring burner near it. A temperature will be there at which when we bring the burner near the nozzle, it will suddenly catch fire. And this fire will not remain there for a long time. It will just be in the form of a spark. So that is called flash point. The temperature is noted and that temperature is called flash point. Any doubt in the flash point?
No, ma'am.
Okay. Now what is fire point? After getting the flash point, after nearly 5 to 10 degrees above the flash point, you will get fire point. So again, after getting the flash point, the same thing we repeat after each 10 seconds. We will repeat the same thing. Tilt the shutter control, open the nozzle, bring burner near the nozzle. Now, if a temperature will be there at which there will be, it will catch fire. Okay, it will catch fire and that fire will remain there. Okay, it will catch fire and this fire will remain there for at least 5 seconds. So this point is called fire point. at which it catches fire and that fire remains there for 5 seconds. That is called fire point. Okay, so this is flash point and fire point. Any doubt in flash point and fire point? Is there any doubt in flash point and fire point?
No, ma'am.
No, ma'am.
So what does flash point and fire point tell us? The safety of the lubricant. The safety of the apparatus in which we have used that lubricant. What? Isn't it?
Yes, ma'am.
Okay. Then viscosity you do by yourself. There is nothing to tell about viscosity. To measure the viscosity, Redwood viscometer is used. Only I am telling you the procedure because viscosity is already known to you. So I am not telling it again. Viscosity is measured by Redwood viscometer. There are two types of Redwood viscometer 1 and 2. One is having a small opening called orifice, and the Redwood viscometer 2 is having a slightly large opening as compared to the viscometer 1. Now, it depends upon the type of our lubricating oil, that which viscometer we are going to use. We are going to use 1 or 2. That depends upon the viscosity of our lubricating oil. If the lubricating oil is highly viscous, then we use Redwood viscometer 2 because it has a large orifice, so it will come out quickly. Okay, and if our lubricating oil is thin, then we prefer Redwood viscometer 1. So it is simply based on the fact that just as we take ink into the dropper, a known volume of ink into the dropper, and if we allow that ink to flow drop by drop, suppose we have taken 10 ml of ink in the dropper and we allow that ink to come out from the dropper drop by drop, and we note down the temperature. That is going to give we note down the time in seconds. This time is going to give us the viscosity of the ink. Similarly, for lubricating oil also we do the same thing. We fill the viscometer with the lubricating oil and we allow that lubricating oil to come out completely from the orifice. Okay, then we note down the time. We note down the time taken by the lubricating oil to come out completely from the orifice. This is going to give us the viscosity. Then we compare it. We compare it with the fresh one. All these tests are generally done after one use of the lubricating oil, mostly. After one use of the lubricating oil, just to check that whether still the lubricating oil is working or not. Okay.
Yes, ma'am.
Viscosity index also I will not tell, just see if you feel any problem in viscosity index. There can be some confusion, you can ask at any time. Viscosity index, iodine value and oiliness. So these are the properties. I will share this slide today. And if you find any problem anywhere in all the 4 units, you can ask at any time. Now you all can leave.
Ma'am, in semester all the units are
over.
All in semester all units पूरा unit से आ गए मैम, मतलब in semester में
सेमेस्टर तो आए, मतलब अभी आपका और सेकंड MCQ 1 और MCQ 2 में जो आपको आ चुका है कितना डिसाइड करता है. देयर कैन बी ऑल द देयर कैन बी होल यूनिट आल्सो, है ना. पूरा MCQ 1